Hello and welcome to my video, which is for the course project for CS201 Computer Programming 1. Today I will be choosing to discuss the topics on Object Orienting Program, or OOP, and all about pointers and references. So what is Object Orienting Program? As the name suggests, it uses objects and programming. Object-oriented programming aims to implement real-world entities like inheritance, hiding, and polymorphism, and etc. The main aim of OOP is to create objects that contain both data and functions. The main characteristics of object-oriented programming are class, object, encapsulation, inheritance, polymorphism, abstraction. So class. The building block of C++ that leads to object-oriented programming is a class. It is a user-defined data type which holds its own data members and member functions which can be accessed and used by creating an instance of that class. A class is like a blueprint for an object. For example, consider the class of fruit. There may be many fruits with different names, but all of them will share some common properties. The fruit is the class, and mango, guava, and bananas are the objects. A class is a user-defined data type that has data members and member functions. Another example is car. Objects can be its brand like Mazda, Toyota, and Ford. Everything in C++ is associated with classes and objects along with its attributes and methods. For example, in real life, a car is an object. The car has attributes also, such as weight and color, and methods such as drive and brakes. Attributes and methods are basically variables and functions that belongs to the class. These are often referred to as class members. A class is a user-defined data type that we can use in our program, and it works as an object constructor or a blueprint for creating objects.
So, class object. An object is an identifiable entity with some characteristics and behavior. An object is an instance of a class. When a class is defined, no memory is allocated. But when it is created, memory is allocated. So object can take up space and memory and have an associated address, like a record in Pascal or a structure or union in C. When a program is executed and the objects interact by sending messages to one another, each object contains data and code to manipulate the data. Objects can interact without having to know details of each other's data or code. It is sufficient to know the type of message accepted and the type of response returned to the objects. So the class methods. Methods are functions that belongs to the class. There are two ways to define functions that belong to a class. One is inside class definition, and second is the outside class definition. Note that you can access methods just like you can access attributes by creating an object of the class and using the dot syntax. To define a function outside a class definition, you have to declare it inside the class and then define it outside of the class. This is done by specifying the name of the class followed by a scope resolution like this operator, followed by the name of the function. Next is the constructors. A constructor in C++ is a special method that is automatically called when an object of a class is created. To create a constructor, use the same name as the class followed by parentheses. like this one. Note that the constructor has the same name as the class, and it is always public, and it does not have any return value. Next is encapsulation. Encapsulation is defined as wrapping up of data and information under a single unit. In other words, it is to make sure that sensitive data is hidden from users. You must declare class variables / attributes as private and cannot be accessed from outside the class. If you want others to read or modify the value of a private member, you can provide public get and set methods. For example, of this chart right here. So the salary, for example, the salary attribute is private, which have restricted access. The public set salary method takes a parameter S and assign it to the salary attributes. So salary equals S. The public get salary method returns the value of the private salary attribute. Inside main, we create an object of the employee class. Now we can use the set salary method to set the value of the private attribute to 50,000. Then we call the get salary method on the object to return the value. Encapsulation also leads to data abstraction or hiding. Then encapsulation ensures better control of your data because you or others can change one part of the code without affecting the others. Next is the inheritance. The capability of a class to derive properties and characteristics from another class is called inheritance. Inheritance is one of the most important features of object-oriented programming. A class that inherits properties from another class is called subclass or derived class. The class whose properties are inherited by subclass is called base class or superclass. Reusability. Reuse attributes and methods of an existing class when you create a new class. For example, when we want to create a new class and there is already a class that includes some of the code that we want, we can derive our new class from the existing class. By doing this, we are reusing the fields and methods of the existing class. So we have three specifiers. Public, these are members of a class. Members of a class are accessible from outside the class. And next one is private. Members can only be accessed within the class. And the third is protected. It is similar to private, but it can also be accessed in the inherited class. So polymorphism. The word polymorphism means many forms. In simple words, we can define polymorphism as the ability of a message to be displayed in more than one form. A person at the same time can have different characteristics, like a man at the same time is a father, a husband, an employee. So the same person possesses different behavior and different situations. This is called polymorphism. An operation may exhibit different behaviors in different instances. The behavior depends upon the types of data used in the operation. C++ supports operator overloading and function overloading. Operator overloading, the process of making an operator to exhibit different behaviors in different instances, is known as uh, operator operator overloading. Operator overloading is the process of making an operator to exhibit different behaviors in different instances. And function overloading. Function overloading is using a single function name to perform different types of tasks. Polymorphism is extensively used in implementing inheritance. For example, suppose we have to write a function to add some integers. Sometimes there are 2 integers, sometimes there are 3 integers. We can write the addition method with the same name having different parameters. The concerned method will be called according to the parameters. Next is the abstraction. Abstraction. Data abstraction is one of the most essential and important features of object-oriented programming and C++. Abstraction means displaying only essential information and hiding the details. Data abstraction refers to providing only essential information about the data to the outside world, hiding the background details or implementation. Consider a real-life example of a man driving a car. The man can only know the pressing the accelerators will increase the speed of the car, or applying brakes will stop the car, but he does not know how on pressing accelerator the speed is actually increasing. He does not know about the inner mechanism of the car or the implementation of accelerator. This is what abstraction is. Abstraction using classes. We can implement abstraction in C++ using classes. The class helps us to group data members and member functions using variable access specifiers. A class can decide which data member will be visible to the outside world and which is not. Abstraction in header files. One more type of abstraction in C++ can be header files. For example, consider the POW method. POW parenthesis method present in math.h header file. Whenever we need to calculate the power of a number, we simply call the function POW parenthesis present in the math.h header file and pass the numbers as arguments without knowing the underlying algorithm according to which the function is actually calculating the power of numbers. So that's our object-oriented program. Next is all about pointers and references. So what are pointers and references? Pointers and references, which are low-level programming, are the most powerful features in C++ language. It allows programmers to directly manipulate memory to efficiently manage the memory, the most critical and scarce resource in computer, for best performance. However, pointer is also the most complex and difficult feature in C++ language. A pointer is basically the same as the other variables, which can store a piece of data. Unlike normal variable, which stores a value such as int, a double, a char, or a pointer stores a memory address. When declaring, variable name is preceded with a asterisk for the pointer. When you declare a pointer variable, its content is not initialized. In other words, it contains an address of somewhere, which is of course not a valid location. This is dangerous. You need to initialize a pointer by assigning it a valid address. This is normally done via the address of operator, and you put the ampersand sign. The address of operator with the ampersand operates on a variable and returns the address of the variable. For example, if number is an integer variable, ampersand number returns the address of the variable number. You can use the address of operator to get the address of a variable and assign the address to a pointer variable. And the other one is reference. So a reference is an alias or an alternate name to an existing variable. For example, suppose you make Peter a reference alias to Paul. You can refer to the person as either Peter or Paul. So when declaring, variable name is preceded with an ampersand with a reference. So when declaring, variable name is preceded with an ampersand in the reference. The main use of reference is acting as function formal parameters to support tests. The main use of references is acting as function formal parameters to support pass by reference. When a reference variable is passed into a function, the function works on the original copy instead of a clone copy and passed by variable. Changes inside the function are reflected outside the function. And a reference is similar to a pointer. So reference or aliases with the ampersand sign. Recall that in C++ use ampersand to denote the address of operator in an expression. Well, C++ assigns an additional meaning to ampersand in declaration to declare a reference variable. The meaning of symbol ampersand is different in an expression and in a declaration. When it is used in an expression, ampersand denotes the address of operator, which returns the address of a variable. For example, if number is an integer variable, number returns the ampersand number returns the address of the variable number. This has been described in the above section. However, when ampersand is used in a declaration including function formal parameters, it is part of the type identifier and is used to declare a reference variable or reference or alias or alternate name. It is used to provide another name or another reference or alias to an existing variable. A reference works as a reference works as a pointer. A reference is declared as an alias of a variable. It stores the address of the variable. And last, what's the difference of the references from pointers? So a reference is a name constant for an address. You need to initialize the referencing during declaration. Once a reference is established to a variable, you cannot change the reference to reference another variable. Number 2 is to get the value pointed to a pointer, you need to use the dereferencing operator or the asterisk. For example, if number is an int pointer, the asterisk p number returns the value pointed to by p number. It is called dereferencing or indirection. To assign an address of a variable to a pointer, you need to use the address of operator ampersand. For example, p number equals ampersand number. On the other hand, referencing and dereferencing are done on the references implicitly. For example, if a ref number is a reference or alias to another int variable, reference number returns the value of the variable. No explicit differencing operator asterisk should be used. Furthermore, to assign an address of a variable to a reference variable, no address of operator ampersand is needed. And now let's proceed to doing our program in the VSC code. So part 2 of the first project is to write a C++ program that will ask the following input from the user, like customer name, age, number of guests, number of days, with the following options and rates of the input, and to compute the total payment as follows. So let's begin. conditions. Must be above 18. Then we're going to be calculating the rates. Daily rate would be 5 greater or equals. Daily rate calculate the the daily rate times number of days. Load. definition. Right. Take pictures. Okay. So that's all for today. Thank you.